So the biggest issue I personally have with electric cars is that as a family, you always need to have a backup. You need that gas car for those long distance trips. That's not just because of the range issue, but also because the charging process takes so much. But what if we could change that? Introducing a solid state battery. What is it? How different is it from our battery options available today? And why the heck don't we already use it in the electric vehicle industry? We'll talk about all that in today's video. To start talking about where we can go with the potential of sodium state batteries, it is best to start with the understanding of lithium ion batteries first. Lithium is known for having one of the lowest densities among metals while also possessing the highest electrochemical potential. In the 1970s, an American mathematician and a physicist with a really good name, John Goodenough, along with his colleagues, identified the development materials that enabled the creation of more efficient and powerful rechargeable batteries. His work was crucial in the development of the lithium cobalt oxide cathode, a key component in lithium-ion batteries. His research laid foundation for the widespread use of lithium-ion batteries, but was it good enough? Now, there are obviously limitations to the current battery industry that are making the world look for alternative options. The biggest one still being the energy density compared to the everyday gas we put into our cars. Just as a perspective, 1 kilogram of gasoline is about 45 megajoules, which translates to 12,500 watt-hours per kilogram. Yeah. Let that sink in. Lithium-ion batteries came a long way since the early 2000s. I mean, we started with about 55 watt-hours per kilogram and got all the way up to 450 watt-hours per kilogram as of 2020. And that is a huge improvement, but still pretty far from where the gasoline is. And based on a German chemistry professor, Jennifer Rupp, we will soon reach a plateau effect. Besides the energy density, another limitation to lithium-ion batteries today is their susceptibility to thermal runaway that can happen when batteries operate in high temperatures or during overcharging. At those high temperatures, the lithium cobalt oxide decomposition generates oxygen, which then starts reacting with liquid electrolyte. You have probably seen those swollen batteries that literally look like pillows. Another reason when you get on the plane, the TSA actually requires to keep all your batteries in the upper cabin with you so that in case of a fire, the crew can actually contain it. Another downside to having a battery or a liquid electrolyte means that any soluble components in the battery can dissolve into the liquid electrolyte and then travel to the anode or the cathode. This can lead to the formation of dendrites, which are branch-like structures of metal that can grow from one electrode to the other. And if those dendrites bridge the gap between the electrodes, it can result in a short circuit, causing the battery to actually malfunction or even become unsafe. So with all those drawbacks, we started looking for a safer and more energy-dense alternative because unfortunately, it was not good enough. So what is a solid-state battery? And that question is a little bit harder to answer because many different organizations are looking for how to make a solid-state battery the best. Even though it's pretty early to say, Toyota car maker went on record and said that they will have a first solid-state battery car in 2025. However, it will be a hybrid, but still, we don't know much of how and with what that battery will be made. But QuantumScape also is working on a mission to deliver high-density solid-state batteries, and they have been working on this technology for years now. And they actually even shipped a prototype cell at the end of last year. NASA also has a project for solid-state batteries called Sabers. Their primary objective was finding a battery that will meet the performance and safety requirements for aircraft's use. They have been working for a long time for the best solution for the electrolyte choice, one that would be easy and affordable to make, but also readily available to source here on Earth. Their power performance target is 500 watt-hours per kilogram. But the basic way of understanding how a battery will differ from the existing ones is this. So a solid-state battery is a type of a battery that uses solid electrolytes instead of liquid or gel-based electrolytes found in traditional batteries. The key components of a solid-state battery are obviously the solid electrolyte, and that electrolyte can be made of various materials such as ceramics, polymers, or combinations of both. And avoiding the use of that flammable liquid electrolyte reduces the risk of fire and internal short hazards, which ultimately makes that choice a much safer option for electric vehicles. And then obviously cathode and anode, similar to other batteries, solid-state batteries have cathodes and anodes, which are typically made of solid materials. Now, QuantumScape actually has a little bit of a different design for their battery because it's anode-free. Solid electrolyte is supposed to take far less space than the liquid versions, which would make those batteries higher in density and a perfect choice for EV applications. Research also suggests that these batteries are capable of recharging 6 times faster. QuantumScape specifies that their battery enables less than 15-minute fast charge. That's 10 to 80%. I mean, that's exactly the problem we have with those EVs now. You can't go on a long trip unless you find a fast charger, which there's not very many of them. You're essentially stuck at a charging station for hours at a time. So less than 15 minutes is all I need to be sold. Now, it is also set to achieve far more charging cycles during its lifetime. And finally, solid-state batteries often exhibit a better stability at extreme temperatures, both high and low. Now compare that to conventional batteries, which is also why NASA is focusing on it. Its ability to have electric planes that fly at high altitudes where temperatures reach way below freezing temperatures. So what has been the issues with all those amazing advantages? It appears that making this perfect solid-state battery with the ability to achieve all those advantages has proven to be simply extremely difficult. And another drawback is the fact that solid-state battery will also require high amounts of lithium, which is a hard metal to source and may also lead eventually to shortages and price hikes. Make sure to watch my last video about sodium-ion battery after this one. It's very, very interesting. But getting back to the video. So the hope is that when they do manage to iron out all those wrinkles, we should be on the path to an even bigger electric revolution. Now let's talk a little bit about the NASA and the Sabers project. So since NASA has been working on these batteries for quite some time with the focus of 5 key priorities, that's safety, energy density, power, packaging for minimal weight, as well as scalability. And according to their website, they say they actually found a way to reach all those 5 challenges with a solid-state architecture that uses a high energy density and high power density sulfur selenium cathode in conjunction with a lithium metal anode. The cathode uses a patented NASA technology called holy graphene technology, which is supposed to provide a highly conductive, ultra-lightweight electrode scaffold, which is the alternative to the highly flammable liquid currently used in the lithium-ion batteries. And since NASA and other organizations are looking for a solution to electrifying the aircraft, solid-state batteries are really the only option. Sodium-ion batteries are greatly safe too, but because of their low energy density, they're not suitable for aviation. Holy graphene is supposed to achieve that goal of lightweight battery solution. And NASA also added another significant and very interesting improvement to their battery design that's called a bipolar stack, where instead of having each cell individually in its own casing like we have done for many, many years in EVs now, it literally looks like a bunch of alkaline batteries stacked together in a car. NASA shows that on their brochure that those cells can be stacked vertically inside one casing, which decreases the amount of steel casing and limits the weight. And that resulted in about 40% lighter battery with 500 watt-hours per kilogram. Comparing that to LFP battery chemistry or sodium-ion chemistry at less than 200 watt-hours per kilogram. And because it is a solid-state battery, we see that long lifetime with a relatively low capacity degradation too. Toyota, on the other hand, has been working on a solid-state technology since 2012, and they have over 1,000 solid-state battery patents. That's more than any other car maker out there. Toyota is targeting an 800 or even 1,000 kilometers range cars by 2027 or 2028, with fast charging of 10 minutes or less for SoC state of charge 10 to 80%. According to their press release from September of this year, Toyota solid-state lithium-ion batteries have a solid electrolyte that allows for faster movement of ions and a greater tolerance of high voltages and high temperatures. These qualities make the batteries suitable for rapid charging and delivering more power in a smaller form. I am personally really curious to learn more about Toyota new batteries because they're not only just talking about improvements or creating solid-state options, but also one with the liquid electrolyte. And interestingly enough, both include price reductions for the cars. We've been focusing here a ton on electric cars, but just imagine how much those long-lasting batteries would help in medical application or even just our phones lasting more than one day. There are still challenges ahead of us, like dendrite formation issues that we have seen in lithium-ion batteries, but if this whole idea with this whole idea, so many big car manufacturers are placing bets and actually buying stakes in those solid-state battery organizations. I mean, we're talking Ford, BMW, Nissan, Honda, Volkswagen, or even NASA creating their own. So the biggest question now is not how, really, even though we do have many options available, but when will we see those options available in electric cars of the future? And it's not really that far away. We're not talking in 10, 15 years. We're talking a solid-state battery car by Toyota in 2027, hopefully. Now, that's just 4 years away. This is absolutely promising, and I personally cannot wait to see it play out. Thank you guys so much for watching. If you enjoyed this video, please make sure to give this video a big like, subscribe to the channel, and I will see you in my next video.